Well, hello class. Today we're going to pick up a second topic, and this is solving radical equations. And they work just like regular equations with one exception. Sometimes you'll get an answer or even two answers that when you plug it back in to check it, they don't work. And we call those extraneous solutions. An extra solution that really is not a proper solution. So with radical equations, you've always got to check to make sure that your solutions do make sense. Now this first problem is square root of 64v equals 8. And to solve for v, we want to get rid of the square root operation, and the inverse of that is to square it. So the square root of 64v squared is simply 64v. 8 squared becomes 64. Dividing both sides by 64, v is equal to 1. Now we plug it back in mentally real quickly. 64 times 1 is 64. Is the square root of 64 8? Sure. And so that does check. Okay, here's a second example. The square root of a plus 6 is set equal to 9. We want to solve for a. So as before, we're going to square both sides of the equation. The square root of a plus 6 squared simply becomes a plus 6, and 9 squared becomes 81. And we're going to subtract 6 from both sides, and so that's going to give us 75. Now let's check it out. Let's put 75 back here. 75 plus 6. Is that 81? Sure. Square root of 81, is that equal to 9? Bingo. That one also checks out. All right, in this problem we've got both sides of the equation are under the square root sign, so to undo that we're going to square both sides like so. And square root of n squared is n. Square root of 2n minus 2 squared is just 2n minus 2. So we've got really a basic equation. I'm going to subtract n from both sides and add 2 to both sides. So I get that n is equal to 2. Now let's quickly check it out. If we put 2 here, we've got the square root of 2 on the left. If we put 2 here, we've got 2 times the square root of 2. 2 times 2, which is 4, minus 2, which is 2. And so sure enough, you get the square root of 2 is equal to the square root of 2. All right, once more, we've got a problem. Both sides are under the square root operation, and so to undo them, the inverse is we're going to square both sides. And so on the left, we have 2n minus 12. On the right, we've got n minus 4. At this point, I'm going to subtract n from both sides, and I'm going to add 4 to both sides. So 2n minus 1 is n. And, well, actually, what I'm going to do, I'm going to add 12 to both sides, excuse me. So if we add 12 to both sides, negative 4 plus 12 is going to be 8. Now, let's quickly plug it in. 2 times 8 is 16. 16 minus 12 is 4. Square root of 4 is 2. Well, 8 minus 4 is 4. Square root of 4 is 2. So 2 does equal to 2. And they check. All right, this particular problem is a little bit more difficult. Before we can deal with the square root operation, I need to get this k over to the other side. And the way I'll do it is I'll add it to both sides. So on the left now I've got square root of 6k plus 43. And on the right I've got k plus 6. Now everything looks fine except that as we square both sides, on the left side, the square root of 6k plus 43 squared drops down to 6k plus 43. But on the right side, we have a binomial squared, so it's going to be k plus 6 times k plus 6. And so we're going to need to multiply that through using the distributive property, and so we're going to end up with a quadratic equation because k times k is going to be k squared. So let's see what we got. We got 6k plus 43 is equal to k squared plus 6k plus 6k is 12k. 6 times 6 is 36. Okay, not bad. Now, from the left side, I'm going to subtract 6k from both sides, and I'm going to subtract 43 from both sides. So I got k squared plus 12 minus 6 is 6. And 36 minus 43, that's going to be negative 7. Okay, now we've got a quadratic equation to solve. Fortunately, this thing factors really nicely into k plus 7 times k minus 1. And using the zero product property, k would equal to negative 7 and positive 1. But we have to check. So let's take negative 7. Up here, we've got a negative 7 plus the square root of 6 times negative 7 plus 43. And we're going to ask the question, does that equal 6? Well, let's see. 6 times negative 7 is negative 42 plus 43 is 1. Square root of 1 is 1. So we got negative 7 is 7, plus 1, 7 plus 1 is 8. 8 is not equal to 6. So that means that negative 7 is not really an answer. In fact, that's what we would call extraneous. And you do need to identify the extraneous solutions, but understanding that those are not real solutions. They're extra, but part of the North Carolina study is for number 6. Once again, we're going to square both sides of the equation. And on the left, we get 4n plus 8. But once again, on the right, we have a binomial squared. So in other words, we're going to end up with a quadratic equation. And so let's keep going. Got 4n plus 8. Using the distributive property on the right side, we get n squared plus 3n plus 3n is 6n. And then 3 times 3 is 9. Okay, moving these things over, I'm going to subtract the 4n. I'm going to subtract the 8. Give me a big fat 0 on the left. So we get n squared plus 2n plus 1. And fortunately, again, this factors nicely. N plus 1 times n plus 1. 1 times 1 is 1. 1 plus 1 is 2. So using the zero product property, we get that n is equal to negative 1. But again, let's plug it in. 4 times negative 1 is negative 4. Negative 4 plus 8 is 4. Square root of 4 is 2. Let's remember that. And over here, negative 1 plus 3 is 2. 2 squared is 4. And clearly, 2 does not equal to 4. So not only is this extraneous, this particular equation has no real number answer.